Okay, so today we're going to go over notes 13, which is rational equations. So it's going to be similar to what we were doing yesterday and the day before, where we have like adding and subtracting those rational expressions and then multiplying and dividing. But now it turns it into an equation, which means once we simplify, our goal is to try to solve for the variable. So we're going to be getting most likely a numerical answer at the end. Okay. So when we talk about rational equations, remember so far we talked about linear equations, quadratic equations, and then rational equations. And I'm just going to give you guys the parent function for each of these. So recall a linear equation is y is equal to mx plus b. Quadratic is f of x is equal to ax squared plus bx plus c. And then for rational equation, we have y is equal to 1 over x. Okay, so when you see rational, you're going to think like a fraction. Okay. So in these examples, just like before, when we were trying to get a common denominator, that is still going to be our first step, especially in these first couple examples where we're adding or subtracting those rationals. Okay. So starting with this, the easiest way to go about these is to make sure that every single component is set up like a fraction, which means that the only one that's not like a fraction is the 6. So I'm going to write that 6 over 1. I'm going to make it a fraction. And then from here, I'm going to make each of these fractions have a common denominator. So what would that be between 2, 4, and 1? 4. So if our common denominator is 4, that means I need to multiply this one by what? 2. Do I need to multiply the second one by anything? No, I mean technically 1, but we don't have to write the 1. And then that last fraction, what do I have to multiply it by? 4. Okay. So I have 2y over 4 plus y over 4 is equal to 24 over 4. Now that I have a common denominator everywhere, what I could do to solve is I could now cross out all those denominators, and I am left with just the equation on the top. So I am left with 2y plus y equals 24. And again, that trick only works if all the denominators are the same. So then from here I simplify in order to solve for y. So 2y plus y gives us,
2y squared.
oh, not 2y squared, that'd be multiplying. 3y, so we're adding them, 3y. So think of this as a 1y. So that's 2y plus 1y gives us 3y. And I bring down the 24, which means in order to get y by itself, what am I going to do?
Divide it by 3.
Divide it by 3. So I get y is equal 8, and that's my answer. Yes. Yes, I'll zoom out so you can see that. Okay, so first step is still getting common denominator. Once we get the common denominators, we can get rid of all the denominators and then just write our numerators as an equation and then solve for our variable. Okay. So then we have this example, and notice that each term is already a fraction, so we can just go straight into finding that common denominator. And what would it be? 2z, right? Because this one has 2, this one has z, and then this one has both 2 and z. So that means in order for them to all be in common, let's just all make them 2z. Which means this first equation, or this first fraction is missing what? Z. Okay, is the second fraction missing anything? What about the last fraction? 2. Okay. So then I simplify this by multiplying the first fraction by those z's. So we have z times z, which is z squared over 2z. Bring down the minus 1 over 2z. And then this is going to be equal to what? 24 over 2z. Now that they all have a common denominator, what do? Cross out all the denominators. Z squared minus 1 equals 24. Okay. So since we have a quadratic in here, that z squared, that tells us we're going to have to factor. And in order to factor, we have to make this equation equal to what? 0. So what should I do? Minus 24 over. So I get z squared minus 25 is equal to 0. And now, in order to factor this, I know that I can factor this by perfect squares. So what is going to be my factors? Z plus 5, good, and z minus 5 gives us 0. And then in order to find the two answers, set them separately equal to 0. So z plus 5 equals 0 means z equals negative 5, and z minus 5 equals 0 means z equals 5. Okay, so these would be our two possible answers. Okay, so if we have a quadratic, we know that we might have two answers. Versus the last one was more of a linear equation because we only had one variable, and that's how I knew I was only going to have one possible answer. So again, when I say that, I'm referring to the exponent here. Okay. Any questions so far? So let's say we're still on the same problem. Let's say you're not 100% confident with your answer. Well, we could go back and we could check. Okay? And if I plug in negative 5 and I plug in 5, I should get a true statement. So let's start with z is equal to negative 5. So that means I have negative 5 over 2, and I'm plugging it into the original equation. Minus 1 over 2 times negative 5 is equal to 12 over negative 5. Okay, so then I have negative 5 over 2. This is going to turn to plus because on the bottom, 2 times negative 5 is a negative 10. So this is going to be 1 over 10 is equal to negative 12 fifths. So notice no matter where that negative is, it's okay for me to bring it up to the top. Typically, you want to bring it up to the top so it doesn't get lost on the bottom. Okay, so in order to see if these are the same, we would get the common denominator. So I would multiply this one by 5 and this one by 2 because I'm using 10 as my common denominator. And this would give me negative 25 over 10 plus 1 over 10 is equal to negative 24 over 10. And here I see negative 25 plus 1 equals negative 24. Okay, so I know this is a true statement. So z equals negative 5 is a solution. Okay, so you would use this if you're not confident on your answers. If you go back and you check and you get a true statement, then you know you did your math correctly. Does anyone want to see z equals 5? It would be, yes, it would be the same thing but positive. Okay. So in the next concept, it says solving rational equations. And what we were doing in that first part is we were solving very simple rational equations, okay, where nothing was too complicated. Because if we look back up here, There was nothing that we had to factor or simplify like we did yesterday. Okay. But then as we go through these examples, you'll notice that we're going to introduce, okay, we need to simplify by factoring, see if anything cancels, exactly like yesterday. Okay, so we're going to do the same concept. We want all the denominators to match. So right now we have x, 3, and 6. So what could be a common denominator between all three of them? 6x. Okay, which means this one would need to be multiplied by what? 6. And then this one? 2x, right? So we want 6x. And then this last one? X. So we had to do something to every single fraction this time in order to get them all to have 6x as their common denominator. So then from here, I'm going to simplify. So I'm going to take the 6 and distribute it in. So I get 6x plus 6 over 6x plus, what would this fraction look like? 2x over 6x, and then finally this is going to be equal to 5x over 6x. Good, so now that I have common denominator, what can I do with them? Cross them out. That means I only need to deal with the numerators. And so this means I have 6x plus 6 plus 2x equals 5x. Okay, and my goal is to get x by itself so I can get a numerical answer. So I want to try to move all my x's to one side and then have my numbers left on the other side. So which side do you guys want to have the x's on, the left or the right? The left, okay, so I'm going to subtract 5x over. So I have 6x minus 5x plus 2x. And then I'm going to move the 6 to the other side. So that means I have equals negative 6. Okay, so that means when I subtracted that 5x over, that went away. Subtracted the 6 to the other side, that one went away.
Why did we subtract the 6?
Because if we want all our numbers to the left, or sorry, all our x's to the left, we need to get all our numbers to the right. Okay.
So we only equal it to 0 when it's squared?
Yes.
I see.
So what would the side on the left be if we combine all those like terms? 3x, that was correct, because 6x minus 5x is 1x. 1x plus 2x is 3x. So 3x is equal to negative 6, which means our last step would be divide by 3. So that means we have x is equal negative 2. So for these type of questions on the test are going to be 2 points. You get a point to see if you can get everything with common denominator, and then you'll get a point for your correct answer. Is this notes 13? Yes, homework 13. Okay. So any questions on this example? Okay, so now we have this one, and notice that the very first number in the front, that 1, is not a what? Fraction. So what are we going to do to turn it to a fraction? Put it over 1. And then looking at all our denominators, what would be our common denominator? A minus 2, because the other fractions already have that. So that means I'm going to multiply this top and bottom by a minus 2. Which all that means is I have a minus 2 over a minus 2, and I'm going to bring everything else down. Everything else didn't need to change. Let me erase that. Okay. So now that I have common denominator, what am I going to do with them? Cross them out, which means I have a minus 2 plus 3a equals 6. And for here, since I just have a variable a, it doesn't have any exponent, I'm making sure that all my variables are on one side and my numbers are on the other side. So it looks like both my a's are already on the left, so what do I need to move over? Minus or plus? Plus the 2. And I have a plus 3a equals 8. And what is a plus 3a? 4a, which means I get a is equal to 2. To 2, right? Yeah, because I divide both sides by 4. 8 divided by 4 is 2. Okay. However, before we can move on from here, what would happen if I go back and plug that 2 in? I would get 0, right? If I was to go back, let's say I do my check, and I'm just going to plug in a equals 2 into my denominators, which was a minus 2. Then I would get 2 minus 2, which is 0. Can we divide by 0? No. So this tells us that actually a cannot be an answer, and that actually there's no solution. Okay, so that's one extra rule when talking about rationals, is because rationals are fractions. We never want a 0 on the bottom. And so far, we didn't have to deal with that anywhere else, okay, because what would happen if we plugged in the last example, negative 2 into this denominator? Would it be 0? No, so it's good. We never had to go back and check until this example here. So if you go back and plug in your answer into the denominators and you get 0, then you're going to write no solution. So let's look at this example. So this is typically how the problems are going to look, okay? Where you have some factoring you need to do, and then you have to get a common denominator after you factor. So notice that 2 my denominators is t minus 3 and t minus 4. That should tell you that if we were to factor this, most likely we would get what as our two factors? T minus 3 and t minus 4. But let's verify that. Two numbers that multiply to 12, but add to negative 7. Negative 3 and negative 4. So this negative 3 and negative 4. And I'm allowed to write them straight into factors because of what? Good. The a value right here in front of t squared is a 1. So good. We just saved us some time of having to go through the process of factoring. So instead of this, we have t minus 3 and t minus 4. Which means in order to get a common denominator between all three, what am I multiplying the second fraction by? T minus 4. And then the last fraction by? T minus 3. Okay. So I'm going to go ahead and start simplifying that. So my first fraction just has the factors on the bottom. That's the only thing we changed. Okay. My next fraction, I'm going to have to take 2t, okay, and distribute it into t minus 4, which means I have 2t times t, 2t squared, and 2t times negative 4, negative 8t. Okay, and then on the bottom is just my common denominator. Okay. And then I'm going to do the exact same thing with 3t. I'm going to distribute it in to t minus 3. And so I get 3t squared minus 9t all over our common denominator. So now that I have all my fractions set up in common denominators, what can I do with the denominators? Cross them all out. So I have 6 plus 2t squared minus 8t is equal to 3t squared minus 9t. Since I have a t squared, so an exponent here, I know I need to get my equation equal to 0. Equal to 0, because that means ultimately what I might have to do is factor. Okay, so how would I make this equal to 0?
Move the 3t squared and then negative 9t over.
So I'm going to do minus 3t squared and plus 9t. Always the opposite signs. Okay. So that means I have 6 plus 2t squared minus 3t squared minus 8t plus 9t equals 0. And then I just have to combine like terms. So what would be my common terms here?
2t squared. 3t squared.
So these ones right here, and then what are my other ones? Good, these ones right here. Okay.
Will we move the number 6 over?
We wouldn't for this case because we want it equal to 0 because we have t squared.
You threw me off with the last question.
When I move
You
the,
guys, because I came in a bit late, so I didn't catch all the information. But I'll ask you.
yeah, no worries, no worries. Okay, so if we simplify the t squared, we have 2t squared minus 3t squared, which gives us t squared or negative t squared? Negative t squared. And then we have negative 8t plus 9t, which gives us positive t. And then I just bring down my plus 6. Notice I made sure I had it written in the correct order. I had my t squared, then my t, and then my constant value. There's one more thing that I would do, though, before I start factoring, and what would that be?
Remove the negative times
Good, and how would I remove the negative? GCF. So if I take out a negative 1, I'm left with t squared minus t minus 6 equals 0. Okay. Which means I now need two numbers that multiply to negative 6 but add to negative 1. What would be those two numbers? 2 and 3, and which one's negative? 3. So 2 times negative 3 gives me negative 6. And 2 plus negative 3 gives me negative 1. Okay. The reason why 6 and 1 wouldn't work is because no matter how we add them together, we're either going to get a 5 or a 7. Okay, and that's not giving us a negative 1. Okay, so since my number in front of t squared is a 1, I can go and write those factors. So I have negative 1 because I'm bringing down my GCF, and then t plus 2, and then t minus 3 is equal to 0. What's my next step?
You would start erasing? Or like terms? No.
No, some
Solve for t by doing what? Setting it to 0. Do I set negative 1 equal to 0?
Oh, no. That's false.
No, because that's a false statement. So then I go to t plus 2 equals 0, which means t equals negative 2. And then I do t minus 3 equals 0, which means t is equal positive 3. So before I stop and say, yes, these are my two answers, what do I need to do with both of those t values? Check which part of the equation.
I thought the negative 2 would be allowed regardless,
Why?
because you can't have a negative number. I think you said something like that in the past lesson.
So that was when we were dealing with applications. So like if like t was time, we couldn't have negative time. But here it doesn't relate t to anything. It's just a variable. So we could have negative 2.
Plug in the t's to the t's in the equation at the top. No. Check.
Yes, but which part? Do I plug it into the entire equation, or do I only care about
The second and the third partial, which is t minus 3 and t minus 4.
Yes, I only care about the denominator. So I only care about these denominators right here, because those are our common denominators.
You plug them in for both answers.
For both. And if I get 0, it can't be an answer. So when I plug in -2, and this is where I could do my check. Okay, and I'm checking in t minus 3 and t minus 4, right? That was my common denominator. For -2, if I do -2 minus 3, that gives me -5. That's okay. If I do -2 minus 4, that gives me -6. Both of those are okay, which means this is an answer.
So it just can't equal 0.
It just can't equal 0. So if I check the next one, and I check 3, 3 minus 3 is 0, which means I don't even need to check the next one. I already got 0, which tells me t equals 3 is not an answer. Okay?
That's pretty straightforward.
Sorry?
That's pretty straightforward, but do you do this with every single answer?
For solving rational equations, yes. We will have to do it with every one because denominators can't be 0. So you wouldn't have to really, I would say, write out the check. You would just go back and think mentally, okay, if I was to plug in -2 to any of these, will I get 0? No. If I was to plug in 3 to any of these, would I get 0? Yes. So that tells me no solution, or sorry, not no solution. This answer is not going to be an option.
There's one answer.
There's one answer. So since we are left with one answer, would I write no solution? No, because I still have one answer. It would be if you had the scenario of both of them cancel out, which means you didn't find any answers, so then it would be no solution. But we had one answer at t equals -2. Okay.
Can you zoom out? Thank you.
About the -1 was just our GCF. And so what we technically do is we say, okay, we go -1 equals 0. That's a false statement, so we skip it. Just like how we set each of these equal to 0. Okay, I feel like this would be the hardest type of rational equations that you would see, at least for this course, okay, where you would have to factor, get a common denominator, solve, and then go back and make sure you don't get 0 when you plug in those numbers, 0 in the denominator.
Where did the -2 came?
Where did this -2?
Oh, no, the option.
You said that this was in the
I would feel like, yeah, this would be here. Did you figure it out? Because I wasn't sure what you were asking. Okay. Okay.
I have a quick question.
Yes.
Back to what I had initially asked.
Yes.
This makes sense, but I'm confused about the last one, finding the no solution.
So it equals to 0 is not a solution.
So for that,
The check, is it?
yeah, so it's in the check. So we only got one answer when we solved that, and that was a equals 2. So when I go to check, I'm plugging in 2 for my denominator, which is a minus 2.
Did we do the same for the one to the left, and the answer to the question to the left?
So I didn't write it over here because if you look at all of these denominators, the only one with a variable is this one, which means the only way that would be 0 is if we got a solution that was 0, and we got x equals -2.
What I'm understanding is each time, well, if we're presenting a problem,
Mhm.
solving for rational equations,
Mhm.
and there's a variable and there is a number. Like, for instance, the second one, a minus 2
Mhm.
equals a minus 2.
Mhm.
That was our denominator, correct?
Yes. Yes.
That's the only time we would check.
Yes. Mm-hmm.
Which is why we did it for the next question. The next question. The one we just finished right now.
Yes, because for this one, we had the denominator of t minus 3 and t minus 4, which means there was two possibilities of us to not get a solution, and that is when t is equal to 3, which we found here, and the other one would be what?
False.
Well, in order for it to not be a solution, I said one of them would have to be t equals 3 to make that 0.
Yes.
What would the other one have to be to make that one 0?
T equals 4.
T equals 4. So if we got like t equals 4, then we know that's also not a solution because it makes it 0.
Will we do the same for the examples on concept 3? When it's just variables, no numbers?
That's a little different. Don't worry, we'll get there.
Okay.
That's a little different. It's not as hard as it looks with
No,
just variables.
Yes.
But we won't have to plug anything back in because there's no, we'll see. We'll see.
Yes.
Okay. Okay. So for this example, the first thing you should notice is what?
Squares.
The 1. What about the 1?
Over 1.
It needs to be a fraction over 1. That's the first thing. Okay, the next thing you should notice is between all the denominators, we have 1p and p squared. So what would be the one in common? P squared, which means we need to multiply this first fraction by p squared. What about this fraction? By p. And then the last one?
By 1.
Technically 1, right? But we don't got to do anything. So we have p squared over p squared minus, what would the next fraction look like? 4p over p squared is equal to negative 3 over p squared. Okay, now that they're all common denominators, what do I do with the denominators? Cross them out, which means I have p squared minus 4p equals negative 3, but this exponent squared tells me I have to have it equal to what? 0. So I'm going to add 3 to the other side, and I get p squared minus 4p plus 3 equals 0. Which means from here I need to do what?
Multiply a times c.
A times c, and that gives me 3. So two numbers that multiply to 3 but add to negative 4. What would be those two numbers?
1 and 3.
1 and 3. Okay, so 1 and 3, both positive, both negative. Both negative. So negative 1 times negative 3. And then negative 1 plus negative 3. That way we get a positive 3 when we multiply and a negative 4 when we add. So that means I can write these into two factors. What would be the first one?
P squared minus 1.
Not p squared because we factored it, so it's not p squared anymore. P minus 1. And the next one?
Minus 3.
P minus 3. The whole thing is equal to 0. And how do I solve for each one? Equal them to 0 separately. So I have p minus 1 equals 0 means p is equal to 1. And p minus 3 equals 0 means p is equal to 3. So if we look at our denominators, remember our denominator was p squared. If we plug in 1 or if we plug in 3, will we ever get 0? No, we'll get 1 squared, which is 1, and 3 squared, which is 9. So that means these are both possible answers.
But we have to check on that, right?
We just checked.
We checked like out loud mentally, right? If we wanted, we could check this way. We could say, okay, my denominator is p squared. So if I plug in 1, that's 1 squared, which is 1. If I plug in 3, 3 squared is 9. None of these equals 0, so we're good. So if it makes you feel better to write it out, write it out. If you feel like you're okay doing a mental check, then do a mental check. I'm not gonna, like on the test, I'm not going to give you points or take off points if you write the check portion or you don't write the check portion. That's solely up to you. Okay. So now let's do the same thing, but now with word problems. Everyone's favorite. Okay, so starting off, it says 10 times. So how would I write 10 times? I would start it off with 10 and mean whatever I write next is in parentheses, right? Because I'm multiplying it. Then it says the reciprocal of a number. We did that last time. How do we write reciprocal of a number?
Reciprocal is it's the flip.
Uh-huh.
Fraction.
1 over the variable, right? And it doesn't give us a variable, so we can use any variable. What do you want to use? N. Okay, so 1 over n. Usually when it says number, my instinct is to use n as well. Because number starts with n. Okay. There's no dumb questions. Next part says is. So what would we write? Equals. Then it says, wait. The 10 times the reciprocal of a number. Okay, that's not the correct is. Is added to 4. Plus 4. They tricked us here by adding a new sentence. Usually it's all in one sentence. So then it says the result, which now we know is equal. Then it says quotient of 22 and the number.
So divided. Quotient is divided. No?
Quotient's dividing. And then you said what? 22.
24 over n.
Why 24?
Oh, my bad. It's all,
20.
24.
Okay, yes, 22 over n. Perfect. So what we did is we created a rational equation. Because if I do 10 times 1 over n, that's the same as saying 10 over n, plus 4 is equal to 22 over n.
Wait, the 1n, is it already flipped?
It's,
Already did the reciprocal?
we already did the reciprocal. Because if we're saying that our number is n, that's the same as saying like n over 1. So if we flip it, that's how we get 1 over n. Okay. So if we want all of these to be fractions, which one is not a fraction? 4. So I need to put it over 1. And then my common denominator would be n. And the only one I need to multiply by n would be which fraction? The 4 over 1. So I'm going to multiply top and bottom by n. So then I get 10 over n plus 4n over n equals 22 over n. What's my next step? Cross out all the denominators, and now I am left with 10 plus 4n equals 22. And then I just solve this linear equation. So what would be my first step to get n by itself? Minus 10. So I have 4n equals 12. Then what? Divide by 4. And so n is equal to 3. And then remember, what was my denominator for all of them? N. If I was to plug in 3 into n, would I get 0? No, right? I would get 3. So is this a good answer?
Yes.
Yes. That's my mental check. Okay, so if you were to see this type of question on the test, it would be worth 3 points. You'd get a point for setting this up, a point for getting a common denominator, and then a point for solving.
Why was it that we didn't distribute 10 over n again? I didn't hear that.
We did right here. I distributed the 10 inside.
Okay,
So-
does it say fraction?
Yeah, so I just did 10 times 1
Right.
and then just kept it over n. Because technically this is 10 over 1. And so if I think of fractions, I could do 10 times 1, which is 10, 1 times n, which is n. Okay. Okay, next one says quotient of 10 and a number. So how would I write that? Quotient of 10 and a number. 10 over n. Now let me make sure this is not a fake is. No, it's a good one. Okay, is means
Is equals
equals. And then it says 2 less than. So that means I'm going to do something and then subtract 2. So I'm going to leave some space in the front. That's why it says 2 less than. And then it says 4 times the reciprocal of a number. So how would I write that? 4 and then parentheses, right? Just like the last time. Because 4 times means 4 parentheses. And then what is reciprocal of a number? 1 over n. So I would say, besides the reciprocal part, like that's important to make sure you're writing 1 over n and not n. I would say the next thing that's the most common mistake is this part where it says 2 less than. Okay. I think when grading the last test, when we had something like this, and I think there was confusion with, okay, you saw less than and you put less than, like the actual less than symbol. Or you saw less than and you did 2 minus and then everything else, which changes the problem. Okay? So anytime you see 2 less than or 2 more than, 5 less than, 5 more than, that number is always going to come last. Okay? Just a heads up. Okay. So then from here, what would be our next step?
distribute the 4 over the 1 over n.
Distribute the 4. There could be several first steps here, right? 10 over n is equal to 4 over n minus 2. Next step. All common denominator, but we didn't do something to the negative 2 first.
Add a fraction.
Make it a fraction. Good, and we do that by putting it over 1. Now we look at common denominator, and we see that the common denominator should be n. So that means the only one I need to multiply by n would be 2 over 1, so this would be n. So then I have 10 over n is equal to 4 over n minus 2n over n. Okay, cross out all the denominators. Now I'm up here. So I have 10 is equal to 4 minus 2n. And then I want to solve for n, so what am I moving over first? The 4. So minus 4, so I have 6 equals negative 2n. Divide by negative 2 to get n by itself, and I have n is equal negative 3. So once I have this answer, I go back to my denominators. And what was my denominator? N. And I ask myself, if I plug in negative 3 to n, will I get 0? No. So is it a good answer? Yes. Okay. This is last concept. And this is solving formulas involving rational expressions. So I would say this skill is important if you plan on going in, let's say, a science, right? Physics. Physics is the one that comes to mind, but let's say physics. Because what these are is these are formulas for different things. And notice in formulas, a lot of them are all variables because you technically find a value in some application problem to plug in. Another name for these are called literal equations. Okay. And what literal equations mean is that it typically has more than one, sometimes more than two variables. Okay, because this is formulas for something. Okay. So the importance of this, be able to understand this skill, is that if you're able to manipulate the equation, just like we've been doing above, we could isolate one of the variables needed and then create a different way to represent a formula. So for example, this first one says solve for k. Okay, so we're going to pretend that every single letter that is not k, we're going to pretend all those are numbers, right? They're random numbers. And k is our only variable. And our goal is to get k by itself. Okay, so in order to do that, we need to get rid of the m times a in the numerator. Any ideas on how we would do that?
Do we make the f times a?
Multiply the f by k. Good. We could do that first. Okay, I multiply both of these by k. And what that does is it removes k from a fraction. And so then I have k times f is equal to m times a. And again, I want k by itself, so what am I going to move over? F. And how am I going to move over f? Divide. Which means k is equal to ma over f, and that's my answer. So the question from earlier is, okay, would we plug this back in to check at our denominator? You see, it's a little complicated to answer that way because, sure, let's think of it that way. My denominator was k. If I replace k with ma over f, would that give us 0? No. So for these literal type equations that have multiple variables, we're not really looking at a restriction here. Okay, we're not trying to find a solution. We're trying to manipulate the equation to have it be solved for a different variable. Because in the beginning it's being solved for f, and we just fixed it so it's being solved for k. Okay, so then we have something a little bit more complicated, because not only is there one z, there's another z. Okay. So we want to get z by itself, which means we're treating x and y as numbers. So what would be my first step?
Multiply x on both sides.
So if I multiply x on both sides, right, and I do that, what's going to happen is that this x is just going to be distributed into here.
Divide.
Multiply both sides by what? Okay, z, that would be the same thing. It'd end up being multiplied in here. Z squared, same thing. It would go in here.
It would answer as z squared.
It would answer as z squared?
The answer would be z squared if you multiply by z.
Yes, but we don't want to complicate z, right? We're trying to get, what did we do over here first to get k out of the denominator?
Multiply it.
We multiplied it. Well, here, z is not by itself and x is not by itself. So we're going to have to multiply by the entire denominator.
So if you multiply by x plus z, and then on the other side it would be make it a fraction and then multiply x plus z?
Almost.
Well, first you would have to multiply z plus x plus z and then z minus z.
Maybe. I don't know. It got lost. There's too many talking. Okay, let's just do this. We start with this. We're multiplying both sides by that denominator, just like we did on the last one. So what happens is that these cancel. Our denominator is completely gone, which means we no longer have a fraction.
We don't have to have two n's. We have to have two z's.
Yeah, we're eventually going to get all the z's to one side, but we don't need to do it right away.
Okay.
Okay, the goal should be get rid of fractions because nobody likes fractions.
We're gonna get the other z back?
We are. Just wait and see. Okay, so then from here, this is what I have. I have y times x plus z is equal to x minus c. Okay, what am I going to do with that y? Multiply it. Okay, so I'm going to distribute it in. So I have yx plus yz is equal to x minus c. Okay. So remember I said I want all my z's to be by themselves, off to one side, because I want to solve for z. So I'm going to try to move everything that has a z in it to the left. Everything that does not have a z in it, I'm going to move to the right. So for example, I'm going to subtract yx. Okay, it doesn't have a z, I'm moving it over. So then I have yz is equal to x minus c minus yx. So what am I going to move over from the right to the left? Because if I want all the z's on one side.
The negative z.
The negative z, right? Remember, I want all my z's together. So am I going to subtract the z, add the z, add the z? So then I have yz plus z equals x minus yx. Do you see where we're slowly going to get z by itself? Because if we look at this yz plus z, what could we take out? What GCF could we take out? A z. And when I do that, I'm left with y plus 1. I took the z away, remember? Z divided by z, that's 1. Now I only have one z. I started with 2, now I have 1. And so my last step to get z by itself would be to do what? Divide both sides by y plus 1. So I have z is equal to x minus yx over y plus 1, and that is my answer. That was super fun. Super fun. This is fun. Like I said, you get to higher level math, it's not as fun anymore. The algebra is what's fun. Okay, any questions on that one? So we still did the same step of getting rid of that denominator by multiplying both sides by the entire denominator. Then we got everything that had a z to one side by itself, took out a GCF, and then divided both sides so we had z completely by itself. There will be questions like this on the test. This hard?
It's just it feels weird.
There may be
It's
one like
letters
this.
As opposed to numbers. It's rough a little bit.
Yeah, it is a little strange at first.
It's hard to see. It's hard to look at.
This is what should make you feel accomplished. Look at this hard math problem we solved with all those letters. No, that's how you know you keep getting better in math and you keep going on to the next level of math. Eventually, your numbers are gone. It's all letters, especially if you go into theoretical mathematics.
How much time did they have to implement letters instead of numbers?
How much time did they have to what?
Implement letters instead of numbers.
How much time? What do you mean?
Just to think of this.
Oh, you mean the original people? You can blame the, I don't know who created it. You can blame them.
No, I think algebra was created by the Aztec.
Aztecs, that sounds about right. It's something like that. So you can blame them. Okay.
The 8 squared and stuff.
Yeah, it is kind of similar to that where we only have the variables. But since that's more related to geometry, a lot of people like that better because it has a picture to follow, and that's the triangle. This does not have a picture to follow. But, okay, more fun stuff. Okay, now we're solving for little b. Okay, so we're going to go through the same exact process because where is little b right now?
The bottom.
At the bottom. So what are we going to multiply both sides by?
2a.
Big B plus little b, right? Big B plus little b, because we want it out of the fraction.
Can we only ever do that to the denominator?
Yes, always. Yes, so that trend that we're seeing for all of these, that's going to happen every single time. Okay, so then we have h times big B plus little b is equal to 2a because these b's cancel out. And that's why we multiply both sides by the denominator, because we want to get rid of these yucky fractions. Okay. Now what?
Do we multiply the h into the big B and little b?
Multiply the h in. So we have h big B plus h little b is equal to 2a. See, we have a number in here.
Wait, why can't
2.
we just divide it if we already know it's how we multiply?
Elaborate.
Like, why can't we just put the line under h?
And like,
Arrows?
oh, I see what you mean.
Just put h under.
And just divide both sides by h?
Yeah.
We can. That is one way. There's no one way to solve this. So we could solve it that way. We'd get the exact same answer. Okay. So this is what she's saying. We have h times big B plus little b equals 2a. Why didn't we just divide both by h? Oh, well, we can. Why didn't we do that? Because I didn't think about that when I was solving the problem. But let's go ahead and look, and we'll see how we have the same answer on both sides. So for the one we started on the left, once we distribute the h, we want only h with the little b. So I'm going to subtract h big B over. So we have h little b is equal to 2a minus h big B, which means my last step would be to divide by
B-A-H. Sorry.
h, right? Because I want b by itself. Good. So divide by h. And so I have little b is equal to 2a minus h big B over h. Okay. And if I was to finish the other side, how she was solving it, I would just subtract big B. And so I had little b is equal to 2a over h minus b, which I know they look different. But the only reason they look different is because we technically would have to turn the b into a fraction and get a common denominator of h. So we would multiply h. And then what happens if we combine those two fractions, we get 2a minus h big B over h, which is the same thing. So I would say method 1. Method 2, I'm sure you can think of a sum method 3 also. There's no right or wrong way to solve as long as you get to the correct answer.
Can you scroll down so I can see the rest of the... that was it?
Yeah, that was it for this part, and I think that's it for the notes. Yep, so right here.